let's take a look at this shift scheduling problem. We're saying it's in a call center that's taking calls for charity, for example. We know hour by hour of the day, and apparently they open at 8 in the morning and they close at basically this is the 11 p.m. to midnight block. And they need a certain amount of people there answering the phones during each hour-long block of the day. We could even graph this and see what their demand pattern is like, so mildly interesting. And we need to schedule our operators in 8-hour shifts. And apparently people who start the day get paid a little bit more. This isn't per hour, this is for their total 8-hour shift, than people who come in at 9 o'clock. And then people who are there near the end of the day, like these people would come in at 1500 hours, which is 3 p.m., and they would be there until 11 p.m. So they're apparently getting paid a little bit extra because they're working into the late night there, or not super late night, but later than the usual 9 to 5. So we need to figure out how we're going to schedule 8-hour shifts to meet our needed staff count in each hour. So take a minute to think about that, pause the video, and when you've thought about it, come back. Okay, welcome back. Here's the first thing that most people say is that I'll just have decision variables, that is how many people I have there at each hour of the day. So I'm going to just start typing here. We'll see how it goes. Number of people there in each hour's time block. It's pretty clear. I would, let's see, I'm going to start coloring these green at least. I would need 5 people there at 8 a.m. I would need 8 people there at 9 a.m. and I would need 10 people there at 10 a.m. for example. Take a sec to think about why this might not end up working. Pause the video if you need to. Okay, welcome back. Well, by the time we get down to here, we'd say, well, I'm going to have 9 people working in that 1500 hour. But how do I have only 9 people if I had like 19 people working at noon, and most of them are still going to be on staff, or, on shift, because that wasn't 8 hours ago by the time I get to 9 p.m. To 1500. So doing it hour by hour like this ignores the fact that shifts are 8 hours long. That's basically presuming that each shift is 1 hour long. And that system wouldn't change if shifts were 6 hours long or 10 hours long or something. There's nothing about the number 8 hours that's present in that. So there's kind of too much freedom from time block to time block there. So now that we've seen that doesn't work, pause the video again and see if you can come up with a way of organizing the decision variables and all that stuff. We're going to undo this. All right, so welcome back from pausing. Here's another way to lay it out. Let's take a look at this and say, well, some people, I'm going to have them start at 8 and then they work until, what, 4 p.m. And they'll get paid $128. And they would be there during the 8 a.m. block, the 9 a.m. block, the 10 a.m. block, etc. But then they wouldn't be there during like the 15 and 1600 block. I might have that a little mixed up, then some people I'd say start at 9. So what I really need to decide is how many people start their shift at 8, how many people start their shift at 9, etc. And then somehow take into account the fact that the people who started at 9 are still there in these other time blocks. So I've got that laid out here. I have a decision variable marked for how many people start at 8 a.m., another for how many people start at 9 a.m., etc. So I've just happened to have some space here. By the way, to get this kind of sideways version of this, what you can do is highlight this and say copy, and then wherever you're pasting, right click and look for this symbol here which says transpose. So that will take whatever columns you have and paste them as rows, or if you had them as rows, it'll paste them as columns. Or another way to do that is right click, choose paste special, and there's a transpose option there. So that's how I took this data here and got a transpose version of it here. So if I, for example, have 5 people or 4 people starting at 8 a.m., they would each get paid $128. So maybe it's a good place to fill in our objective function value. We'll color that orange. So go ahead and put a formula here that tells me how much I'm going to end up paying people for their shifts based on how many people I have scheduled to start at each shift time. So you probably guessed that it's a sum product, and we'll do the sum product of, let's see, these with those. And usually whatever I highlight for the decision variables is going to be used over and over again, so I'm going to lock that reference. Now I need to think about how many people we're going to have working in the 8 a.m. hour, how many people we're going to have working at the 9 a.m. hour, etc. So we'll say here number working that hour, and we'll have a needed that hour. And for needed that hour, we'll just say equals that one. And then we can fill this down. I could have copy pasted, but if you've got a table up here already, it's kind of nice that if you make a change here, that not that we're planning on a change, but if you're actually doing this for an application, you kind of have to figure that, oh, the needed number of staff might change from week to week, for example. So it's nice to have an automatic updated version over here. So how am I going to compute how many people are working in the 8 a.m. hour? If I have 5 people starting at 8 a.m., let's say I have 3 people starting at 9 a.m., etc. Are these 3 people working in the 8 a.m. hour? No, they're not. How many of these 5 people are working? All 5 of them. Or you could say, like, let's say I wanted to do a sum product here. I'm going to copy this, copy, and then just paste the formula because it's not an objective, so I don't want it colored orange. And in fact, I can do all that, and these will be left-hand side, so I'm going to color them kind of lilac. I'll say that's lilac. And these will be right-hand sides, and I'm going to color those kind of a rose. We'll call that rose. Okay, so since I want to use a sum product here, what numbers do I need to put here to say how many people are working this hour? Take a minute to think about that. Pause the video if you have to. Okay, welcome back from pause. You might say, of these 5 people, how many of them, per person, how many of them are there at 8? Well, if I have like 1 person starting at 8, then I have 1 person working. If I have 5 people starting at 8, then I have 5 people working. So this is kind of like, are these people here at this hour, yes or no? What about the people who are starting at 9? Are they there in the 8 a.m. hour? No, they're not. So I'm going to put a 0. Or you could say 0% of them are there versus 100% of these people are there. Again, the people at 10 a.m. are also not there, 11, 12, etc. Okay, how about the 9 a.m. hour? Who's there at 9 a.m.? Well, the people who started at 8 are there, and the people who started at 9 a.m. are also there, but then the people who start at 10 are not there. So are you seeing the pattern here? So I can say 1, 1, 1, 0, 0, 0, 0, 0. So go ahead and fill out the pattern. Pause it if you need to. All right, welcome back. And then what are we going to have here? At some point, like these people who started at 8 a.m. are not going to be there at 2300 hours, and they're not there at 2200 hours. That's 10 p.m. When's the last time they are there? Well, if a shift is 8 hours and each row is an 8-hour block, then there should be 8 of these ones to show which hours they're there in. So there's 4, 6, 7, 8. And in the hour block starting at 1600, that's 4 p.m., those people who started at 8 a.m. are not there anymore. Apparently, we're not giving lunch breaks. If you wanted to do an hour lunch break, that wouldn't be so bad. You'd put a 0 here or there and then just put another 1 here. If you wanted to do a half-hour lunch break, I guess you could do like a 50% here. You'd have to think about that. Or you could do half-hour long blocks, for example. and then you'd have twice as many blocks, and maybe twice as many variables, because you could start some people at 8, so you could start some people at 8:30, etc. So now that we've seen the pattern, it's 8 ones in a column and then all zeros. So I'll try that. Boop, boop, boop. And then one nice thing about some product is that even if you have a blank cell, it will treat it as a 0, which matrix multiplying in Excel, which we might see later, will not do. But for some product, I can actually just leave those rows blank, or I could put zeros in. It's kind of nice to put in zeros just so people know that you didn't forget to put something there that you really mean for that cell to be a 0. For now, I'm just going to skip all the tediousness of typing in the zeros. So, are we ready? It'd be nice to say, do I need a less than or equal to here, greater than or equal to? Well, I need at least that many. All right, and I think we're ready for solver. So pause the video and set up solver before you watch me do it. Okay, welcome back. So let's see, my objective is that, and I want to minimize total cost because I'm the manager and it's my job to minimize cost by changing these cells subject to what constraints. All of these cells have to be greater than or equal to all of these cells. And that's pretty much all the constraints I have. So I'm going to say OK. This is a linear program. I'm just using some product, so I'm going to choose that. You might notice there's something I'm not specifying, which is OK. We'll come back and talk about it in a sec. So let's just hit solve. That says solver found a solution. All constraints and optimality conditions are satisfied. So did we get reasonable results here? I think we did. It would have been nice to put this one in dollar format because it's a dollar amount. So that's our first scheduling problem. And what's the main lesson here? It's, what would you say? Not having variables like one for each hour exactly, because then you lose the link about shifts, and indicating yes/no decisions that we made before running solver using zeros and ones rather than using if statements. Now, there is actually a way to put an if statement here that will compare this 11 a.m. to this starting at 9 and put a 1 or 0. Maybe I'll do that in a different video, or you can just ask me about it. But this idea of communicating structure of a linear program by having zeros and ones in just the right places, even though the decision variables are not just binary, right? These are not just binary values. A few interesting things here. I think if I remember correctly, there are different optimal solutions here that give the same total price. I mean, that's what it means to be optimal, same price as some other arrangement. It kind of depends on how you start your solver. So if you start with all zeros, for example, and then run solver, you might get something different. Sometimes it's kind of hard to predict. So solver found a solution. I think that's the same solution. Other things that could happen, we'll put all zeros here again. If I had run GRG nonlinear, sometimes when that runs, oh, here it happened. Look, it gave non-integer results. When running the linear problem, gave integer results, so that's interesting. And we'll talk more about that later. What I didn't do is say I want constraints that these have to be integer. So I can add that, choose the integer option here, not binary. We want to be able to staff more than one person in a time block. So then if I hit solve, so that's a different solution than the first one I got, but it still has the same overall price. So in general, if you know the problem is linear, run the linear solver, simplex LP. If you run the GRG nonlinear, you might get solutions that aren't quite integer when they really might naturally end up being integer. And a solver will run faster if it's a linear problem and you tell it's linear. So this is a fairly small problem. I I had a student once who had a friend or relative in the public safety business, and they were evaluating should our shifts be like 8 hours long, 9 hours long, 10 hours long. If it's 10 hours long, then just 4 days a week. And so that student set up a similar problem to this, but they were doing 8-hour shifts 5 days a week, or maybe 4, and starting at each different hour of the week. So they had this problem where they had 168 variables, 168 rows. There's 168 hours of the week, and bands of ones and zeros and stuff. So that was a really interesting project. All right. 2 more things. We can go back here and graph hours of the day, how many people are scheduled to work, and how many you needed, and see how we're doing on that. So apparently this dip during the mid-afternoon, there's no way we can handle that with 8-hour shifts. We just have to staff so many people here that they end up carrying over. So maybe you could offer some shorter shifts, maybe some part-timers. Another issue with this, and we'll talk about this kind of thing more, this isn't saying who is coming in at 8 a.m. and who is coming in at 4 p.m. If the boss feels like it, or if there's some other fancier part of the program, it could have someone coming in at 4 p.m., working till midnight, and then scheduled to come back the next day at 8 a.m., which would not be enough time for 8 hours of sleep. That kind of thing, maybe you've heard of it, is called clopening, like closing out one day and then having to be there for opening of the day the next day. And it's really hard on people, and if you don't program into your linear program to avoid clopening, it might accidentally happen. And I think some states are now passing laws against scheduling people for clopening. Another issue is if you run a program like this every day to schedule people, people's schedules will be unpredictable, which makes it hard to arrange childcare, makes it hard to go back to school because you don't have a predictable job schedule to match your class schedule. So there's all kinds of optimization and society issues to think about here.